Another important concept for Design Modeler is the states of the bodies. Bodies can either take on an active or frozen state, and these are the only two states available for bodies. The state of the body determines whether bodies can be brought together into a single part or not, such that active bodies will automatically merge with bodies in contact or overlapping. So if we have two bodies which are sat next to each other, they don't share any topology in any way or any entities, but if we then enable both to be active, it allows these bodies to be merged together. If one or both are frozen, it prevents them being merged together into the same part, and both of the bodies remain independent. And this is important from a couple of key perspectives. From the meshing point of view, so much as it allows, if the bodies are merged together, there will then be a consistent mesh all the way through the combined body set. And as far as the solver is concerned, if we have separate independent bodies, this means that we can assign different models or physics to those particular bodies, and we can basically treat them independently. For example, one body we could actually define as a fluid region, and the other body we could define as a solid region, for example for a conjugate heat transfer case as an example. So this allows us to have some control over the definition before we actually move into the simulation itself. Okay, so a bit more detail on active body states. The example here is we have a block, and then part of the block, or the face of a block, a semicircle face of the block, has been extruded. And what we've done is, during that extrusion, we've simply selected in the details view the operation to add material. Add material is effectively adding to the existing material, such that the newly formed body will be a part of the existing body. And so in that sense, we're extending the existing body into the newly formed body. And when it's formed as add material, by default it's displayed as opaque, so that we can't see through it, as shown in the top right hand corner of the screen up here in this example. And we also see a blue icon under the tree outline. So here we can see this blue cube here listed against the active body, which is called solid. The name solid, by the way, that's not a reference to the type of material that this body will take, but that is purely the name or the string that identifies, that represents the name for that body. But here we can see this opaque blue icon representing that it is a body where it's an active body, it's not a frozen body. So now we move to the second option of adding as frozen. Here we have the same example of the cube, and we extrude this face, but instead of selecting add material, we drop down to add frozen. So when we add frozen, this then allows each of these two bodies to be treated independently, and these two do not combine into the same body. So now we have two separate bodies. We have the opaque body, which is the one on the right, which is the active body, and then we have the frozen body, which is the one on the left, which is the which can be seen as the translucent body here on the left. And here we can see that reflected in the tree structure as the opaque and translucent bodies. Both take on the same string name, which is of note here, which you can edit to form a different name if you want to call them something else, for example fluid and solid, or water and steel, or something like that. For example, you could change them to that, but you have to be just aware of the graphical representation to indicate to you the status of the body, and it's also indicated in the tree structure as well.